Hi Algebra 1, just finishing up our investigation of fractional exponents and wanted to finish it off with a warm-up and some additional problems to think about. First of all, a reminder of properties of exponents. The first property of exponent that we've already explored is the product property. And the product property tells us that if we have the same base, so same bases that are multiplied together, we are going to add the exponents. And that's what we're going to be doing here. Our other two properties were the quotient property of exponents. And the quotient property says if we have the same bases, we will subtract the exponents. And the last property of exponents is the power property. And when we have the power property, that's a base being raised to a higher power. So here's a quick example. If we had a to the second to the third, we would multiply those powers together. So product property, quotient property, power property, we're mostly going to be using the product property here. So in the first one, we have 3 to the third times 3 to the fifth. It would not be a good idea to evaluate both of those first. It's a better idea to realize that we have the same base and we are multiplying. If we have the same base and we're multiplying, we will add the exponents together. So if we have 3 to the third times 3 to the fifth, we are going to keep that base and add those exponents together and get 3 to the 8th. Now 3 to the 8th is quite a large number, so we're just going to leave it as 3 to the 8th. That is simplified enough for our purposes. Number 2 is different. Number 2 is different in that we do not have like bases, but we do have bases that are related. Both 4 and 8 are powers of 2. So powers of 2. Let's write some over here so we can think about them. Powers of 2. Let's start with 2 to the first. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16th, and so forth. These numbers are just doubling every time. If we keep going down, 2 to the 0, of course, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And we've also learned that if we have negative exponents, that negative exponents make reciprocals. They make fractions. So 1 divided by 2 would be 1/2. So those are some basic powers of 2. Now what we see here is that 4 is 2 squared and 8 is 2 to the third. So we're going to make an equivalent substitution first for the 4. We're going to replace the 4 with 2 squared. And then obviously we're not replacing that. That stays. And then we have 8, which of course is 2 to the third. I'm going to replace 8 with 2 to the third. And it is going to be raised to the 4th power. Now we're going to be able to use the power property to simplify. So here we've got 2 to the second to the negative third. Power property says if we have a power being raised to a higher power, we multiply. That's what I'm going to do here. This becomes 2 to the negative 6th times 2 to the third to the fourth. Use the power property. 2 to the third to the fourth, multiply, and we get 2 to the 12th. Now we can finish this one off by utilizing our product property. I have the same base. I will keep that base, and all I need to do here is add the exponents. Negative 6 plus 12 is 6. And we can just leave it 2 to the 6th. That's just fine. So if we can do that with 2 as a base or 3 as a base, can we use the product property if we have a variable for the base? Yes. And we've already been talking about how so many times the variables are the easier things to deal with, and they still are. The product property is still in play. If we have a to the 1/2 times a to the 3/8, we're going to keep that a. We're multiplying. The bases are the same. We are going to add those exponents together, even though they're fractions. Fractions are our friends. We've just got to learn to work with them. So we need to know, well, what is 1/2 plus 3/8? In order to add fractions, we need a common denominator, and the common denominator here is 8. So we're going to multiply by 4/4, renaming that fraction like we've talked about in class. So we have 1/2 being renamed as 4/8 plus 3/8, and we end up with a to the 7/8 power. When we add those fractions together, we add the numerator and keep the denominator. That is where the 7/8 power is coming from. Now, we're going to be doing some more of this using those same properties of exponents in order to simplify. So first, we've got another one similar to number 2 that we just did. We have 2 to the 1/4 times 8 to the 1/4. Both 2 and 8 are powers of 2. So there's no need for me to change 2 to the 1/4 power. It's just fine. So we're going to keep 2 to the 1/4. But the 8 we are going to replace with, if you recall, 8 is 2 to the 3rd. We're going to replace 8 with 2 to the 3rd power. And it's still, of course, to the 1/4. So now we're going to use the power property, which when we have a power being raised to a higher power, we multiply those powers together. So 2 to the 1/4 times 2 to the 3/4. 3 times 1/4, if you look at it, it looks like that. 3 times 1 is 3. 1 times 4 is 4. We get 2 to the 3/4. Now, 2 to the 1/4 times 2 to the 3/4. Keep that base. Apply the product property. The bases are the same. Add the exponents. 1/4 plus 3/4 is 4/4, and of course 4/4 is equal to 1. The whole thing is 2 to the 1st power. Let's do it again. We can change 16 and 4. We can change them to powers of 2 or powers of 4 because 16 is 4 squared. Let's use 4. We're going to make an equivalent substitution for 16. So 16 is 4 squared. 4 squared raised to the 7/6 power times 4 to the 7/6 power. So from here, now use the power rule. The power rule says that we are going to multiply those exponents together. So we end up with 4 to the 14/6 times 4 to the 7/6. Once again, the bases are the same, so keep that base and add the exponents together. So 14/6 plus 7/6, that's 4 to the 21/6 powers. Now, for our purposes, I just want to know that you know how to apply the properties of exponents. So let's just leave it 4 to the 21/6 power. The only other thing that would be okay is if we just reduce that fraction. Since both 21 and 6 are divisible by 3, we could change it down to 4 to the 7/2 power. That would also be a great answer, but I would happily take either one of those. Next, last two problems. If we have 3 to the 3/4 times 3 to the 9/4, this one's really simple. We've got like bases already. Keep that 3 add those exponents, 3/4 plus 9/4. We've already got a common denominator of 4. We end up with 3 to the 12/4. 12 divided by 4 is 3. We end up with 3 to the 3rd. Anytime that we've got one that's this simplistic, let's go all the way and evaluate it. 3 to the 3rd is 3 times 3 times 3. That is equal to 27. Next, 128 to the negative 3/4 times 2 to the negative 3/4. Now 128 is out there, so we better think about some powers of 2. So if we write down some powers of 2 here, so let's start at 2 to the 1st again. That's 2. 2 squared is 4. 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. I'm just doubling the number every time. 2 to the 6th is 64. 2 to the 7th is 128. If we were to keep going, 2 to the 8th would be 256. So, can we replace 128 with the power of 2? Yes. 128 is 2 to the 7th. So I'm going to do an equivalent substitution for 128. It's 2 to the 7th raised to the negative 3/4 power times 2 to the negative 3/4 power. Use the product rule, and the product rule tells us, the power rule tells us that we are going to multiply those exponents together. So we end up with 2 to the negative 21/4 times 2 to the negative 3/4. We've got like bases now, and once those bases are the same and we're multiplying, we can add the exponents together. So we've got negative 21/4 times negative 3/4. Even though they're negative, even though they're fractions, we're still going to add them together. We get 2 to the negative 24/4. Negative 24 over 4 reduces to negative 6. And we're not going to leave a negative exponent. We know that a negative exponent means a reciprocal. So let's rewrite this using a positive exponent. So we will reciprocate and get 1 over 2 to the positive 6. And we know that 2 to the positive 6 is 64. So let's substitute that in there. So we've got 1 over 64 for the final very best answer. So here's one more look at that whole problem. Look at what we did. We replaced 128 with 2 to the 7th. We got like bases after we used that power rule, and then we added those exponents together. Let me correct that sign right there. We added those exponents together because the bases were the same. So we've got 2 to the negative 21/4 plus negative 3/4. That is negative 24 over 4. And then do the division. We get negative 6. 1 over 2 to the 6. Remember, we are reciprocating the fraction 1 over 2 to the 6. And 2 to the 6 is equal to 64.